Hello, geometry. We are on lesson 11.5, volume of prisms and cylinders. Volume of prisms and cylinders. So the volume of a prism or cylinder is going to be determined by the area of the base, what we note as B, times H. So V is going to equal area of the base times the height of the prism. All right, height of the prism. So we've got some pictures here of some different types of prisms. We've got a triangular prism, we've got a trapezoidal prism. This one's a square prism, not a cube, but a square prism. We can see that this face is a square, and then this face right here is a rectangle. This one is a pentagonal prism. So we have lots and lots and lots of different types of prisms. The notes that we did the other day, 11.3, have almost all, if not all, of the different types of bases and their area formulas on them for this guy right here. So I highly recommend that you keep him close. You know exactly where he is because you will use it a lot for this lesson. Cavalieri's principle says if two 3D figures have the same height, right? If two 3D figures have the same height and cross-sectional area, as in if I took a knife or something and were to cut these, they would have the same shape, right? So the same shape, the same area at every level, then they have the same volume. All right, then they have the same volume. So these two triangular prisms have a height of h, and their area of their base, their B, is exactly the same. Therefore, they have the exact same volume according to Cavalieri's principle, right? So we're going to be using that a little bit for when we are working on some of these problems. Volume of cylinders, volume of cylinders. This is a special case of a prism, basically. All right, so we have a height here, and we know that the volume of a prism, I'm going to copy it down again, is the area of the base times the height. Well, we actually know what the area of the base, if it's a circle, is. The area of the base would be pi r squared, and then we have to times that by h. So a cylinder has the volume of pi r squared times h. The last thing, and we're going to come back to this in 11.7, I believe, is similar solids. So if two similar solids, aka two similar three-dimensional figures, have a scale factor of k, then the ratio of their volumes is k cubed. We looked at similar solids, or similar figures, I should say, back in chapter 8. We talked about their sides, their ratio scale factor k of their sides. We also talked about their scale factor for perimeter and area. So in 11.7, we'll come back to area a little bit more and get into that. There's some interesting relationships. So our setup for this would be side of A over the side of B. If we take that scale factor and we cube it, that will equal the volume of A over the volume of B. So we need to find the volume of these similar, not smaller, it should be, or of the smaller solid, excuse me. We need to find the volume of the smaller solid, and they are similar. So that means I need to take my 10 over 5, and I'm going to cube it, because that's the side of A over the side of B equals volume cubed equals volume A over volume B. And I'm going to take 180 over volume of B. Well, when I cube this, I get 1,000 over 125 is equal to 180 over volume of B. So now I need to cross multiply. So I get 1,000 times the volume of B is equal to 180 times 125, which is 22,500. And now I have to divide by 1,000. So volume of B is 22.5. 22.5. All right, we're going to turn this over and look at some more prisms and try finding their volumes, all right? So, for our first one here, we are looking at a cylinder. The cylinder has a height of 10. Remember, all of these will have the formula V equals B, area of the base times the height, or V equals capital B times H. We need to figure out, because this is the diameter, we need the radius. So that means we need half of 12, so the radius will be 6. Because we have a circle, we know circles have an area of pi r squared. So that is the formula for B. So I'm going to plug in pi r squared times h. So we have pi times 6 squared times 10 for our volume. So our volume will be 360 pi, which is approximately 1,130.4. And let's just call this units, because I didn't give us anything to go with, so units cubed. The next one here, we have a triangle. The area of the base for a triangle is going to be 1/2 base times height. And then this guy right here is the height of the prism. All right, the height of the prism. So we know our base is 4, we know our height is 5, so I'm going to plug this in. We've got 1/2 b times h times h. If you need to differentiate those, that is fine. So we've got v equals 1/2 4 times 5 times 6. So our volume in this case will be 60 centimeters cubed. Some students, because they don't like having two h's there that represent different things, right? Some students like to capitalize the second h. I'm okay either way. Our next one, number 3 down here, says to solve for the height. Solve for the height. So we know the volume is 360. This is a rectangle for sure. We don't know it's a square. It's definitely rectangular. So we can do our V equals BH. B in this case is going to be the base times the height, or length times width, however you like talking about that with rectangles and parallelograms. So we've got V equals B times H times H. This is the height of our prism, which is this guy right here, excuse me. So 2 is going to be our base, and then x is going to be our other h. So I know I have 360 is equal to 2 times x times 15. So that's really 30. When I divide 30x, when I divide by 30 on both sides, I get an x equal to 12. Our cylinder here, we know that the volume is 192 pi. V equals B times H. Remember that base, because it's a circle, is going to be pi r squared times H. So we have 192 pi equals pi r squared, and then our height right here is 12. Our height right here is 12. So I need to divide both sides by 12 pi. Divide by 12 pi. My r squared is equal to 16. When I square root both sides, we get a 4 is equal to r. 5 and 6. 5 and 6. So for number 5 here, we have a pentagon. From 11.3 part 2, I believe it was, we know that the area of a pentagon is 1/2 the apothem times the perimeter, right? This is a regular pentagon, so I did not mark those on there, but I'm going to tell you right now, all of those sides are congruent. The apothem we've been given, that's our 8 here. The perimeter we can find, because perimeter is the side length, which is our 12, times the number of sides. Well, if we have a pentagon, then that would be 5. So perimeter is going to be 12 times 5, which is 60. So we know our perimeter. And then to find the volume, oops, that does not go there. Our volume is going to be the base times the height, area of the base. So 1/2 A times P times H. And our H is right here. It's the 20. So I'm plugging in what I know. We have 1/2. Our apothem is 8. Our perimeter is 60. And our H is 20. So we get a volume of 4,800 units cubed. All right, our next one right here is a trapezoidal. Trapezoids have an area of 1/2 H times B1 plus B2. So our volume will be 1/2 H B1 plus B2 times H. This 32 right here is the height of our pyramid, our prism, excuse me. So we have 1/2, the height of our trapezoid is 15. Our first base is 22. Our second base is 6. And then we plug in our 32 for that height overall. So when I type this into the calculator, I get 6,720 units cubed. Be careful with how you round this, all right? Hopefully this feels pretty straightforward. We're really just adding on that times height. So you really need to have the notes from 11.3 with all the different formulas for the areas of polygons in order to be successful on this lesson. Please email me if you have questions. Skills practice is posted to Big Ideas.